Hello, my name is Dr. Jeff Aberle, and I'm going to do a short video here describing the differences between continuous wave lasers and superpulse lasers. Now, if you already own a laser or are looking at purchasing one, you've probably already talked to a salesperson that is selling a continuous wave laser. And these are the most common lasers out there on the market right now. And I want to compare that to a superpulse laser so that you can see the difference. Because there's limitations to continuous wave lasers that superpulse lasers have overcome. And the biggest thing is that you get more depth with less heat with a superpulse laser versus a continuous wave. Okay, now it says continuous wave, but don't let that fool you. They are still pulsed. They're just not super pulsed. So point being is that these values here of the actual laser power from 0 to 15 watts in this situation is limited. You can only go to 15 watts per laser, and you add them together, you can go a maximum of 45 watts, for example, with this hypothetical situation here I've put together. So normally these are pulsed much faster, and if you zoom in, you can just tell that they're just on and off much faster. Now versus a superpulse laser, which has some very interesting characteristics. So I'm going to bump this up to 100,000 hertz, which is 100 kilohertz. And all you see is this big white rectangle here. But if I zoom in, you'll actually see that this is a waveform with all these very, very narrow pulses that go up really high because they're very powerful. So the way I have this right now, this is set up to be 1500 watts peak, or 5800 watts peak. And so that goes up that high. And so right now this is set for 5800 watts peak. So the laser actually pulses to 5800 watts, but only for this narrow time frame, which is 35 nanoseconds. Now 35 nanoseconds is in decimal form 0.000000035 seconds. So that's how long this pulses. It's very fast. And you'll see that they're just repeat. And then there's this long downtime where there's nothing coming out of the laser in between the pulses. So what does that give us? It gives us an advantage of we can get a lot deeper, because when that pulse is on, it's going in 5,800 watts worth of depth, and whatever that is. And that's I can turn this down all the way to 10,000 hertz, and I can get 132,000 watt pulses out of this machine. Now, sometimes it doesn't let me zoom in here on these. Here I can in this one. So this is even more narrow. This is only 7 nanoseconds, where the other one was at 35 nanoseconds. So 7 nanoseconds is 0.000000007 seconds. So that's how long this pulse is on. And it's a special type of laser. You can't use laser diodes to do this. They just can't switch on and off fast enough. So it's a special type of laser that can do this and can deliver these high peak pulse powers. So this number here will give you depth. This is the number that determines how deep you can get. This number determines how many photons you actually get out of the laser to do the work. But this number determines how far these can go into the tissue. So it's always a balance. So it's you're trying to get as deep as you can in a lot of situations, like if you're working necks or quads, or trying to get the deep compartment in a calf, right, or in the lower leg. You want high peak pulse power so you can get in deep. And then the average power you want kind of as high as you can get to, so that you can get the photons out of the machine to actually do the work. Because these are actually what do the work to the cytochrome C oxidase enzymes. And I don't know if you know this, but lasers work by a photochemical reaction. They're not working by heat. The heat is not what you want. You're trying to avoid the heat. But with any type of energy you put into the body, you're going to get heat. But this photochemical reaction that's affecting the cytochrome C oxidase enzymes is what we want. And the more photons we can deliver, the better. So you say, well, 9.2 is nothing compared to the stuff that's out there on the market. And I'm like, well, this is an average. And if you're looking at continuous wave, the averages are usually half the powers that they advertise. So if you have a 45 watt laser, well, the average power is right around 22.5. If you're running a 50% duty cycle. So this isn't peanuts. This is a great number, believe it or not. But you can actually change this so you can get more average power out of the machine and then less peak power. Now this is 67,900 watts peak power. That's amazing. That would be incredible depth. I mean, that's much deeper than like a 15 watt laser. And I say that because each individual laser of a continuous wave is actually what determines the depth. You can't just add them together. It doesn't work that way. And I explain that more in my other videos. So the machine can put out a total of 20 watts average, which would be equivalent to like a 40 watt continuous wave laser. But then if I put in the average output power of 20, I get 5,800. So this is a laser by Laser Biotech, and it's called the Q laser. And the Q has something to do with the actual laser that's in it. You can call them and ask them more about it if you want. But I'm just trying to get this the word out about these super pulse lasers because they really work wonderful. I'm often somewhere down in, I don't have all the values in here, but I'm usually running this level right here, or I can knock down the peak pulse power and get maybe 12 watts out of this. And that's in between 10 and 20,000. Like I say, I didn't put those numbers in here, but that's where I oftentimes run my laser, and the results are just amazing because I get the depth. And the depth is really what it's all about because you got to get the blood to the surface, and the blood's literally coming from the deeper tissues down low, which these lasers just have a very difficult time getting to. Even though they have a lot of average power, they don't have the peak power. The peak power is limited to each individual laser here. So this can only get 15 watts worth of depth, where this Q laser can get 132,000 watts worth of depth. Now, whatever that is, I don't know how far this goes in. It'd be nice to measure. All I can tell you is that things let go when you shine it on them, and that's really all that matters. So anyway, just a general quick explanation between the difference between super pulse and continuous wave. I've made some other videos that go into this in more detail, and you might want to watch those if you're interested in buying a laser or you're interested in upgrading the laser. So anyway, my name is Dr. Jeff Aberle, and thank you for watching.